The door is shut. Are we ready, or do I need to wait a moment?
I think he's talking to you guys. Are you guys ready?
Yeah,
we're going to start.
Good? Okay. Yeah. All right. Well, thank you guys for coming to my talk, Fuzzing Basics, or How to Break Software. And by the way, that is me on a really bad day, so just want to let you know that. I'm Grid or Scott. I'll answer either one, whichever. I'm a husband. My wife's in the back, so if you see her, be nice to her. I'm an avid scuba diver, so if you're a diver and you know some good scuba spots, hit me up. I'm a hacker and breaker of software, but like I tell my boss, I only use my powers for good and not for evil most of the time. And I'm a security worker bee at Company X. My boss had asked me not to divulge where I work, just so I don't embarrass him.
Does it work?
What's that?
Does it work?
Yeah, some of the times. Okay, agenda, why fuzz? I'm going to show you some fuzzing methods, types of fuzzing, some fuzzing software. I've got lots of examples and samples, and those will be on my GitHub page that you see there. I'm going to try to get them up there before the end of the con, but not certain of that, but they will go up there right after, if nothing else. Some tips and tricks regarding fuzzing, and then leave some time for some questions and comments. Okay, starting off. First of all, don't be this guy. Don't test your code in production, but you know that doesn't always work. I've done it before. But why fuzz? It's fun to break software. I was a programmer for a very long time, so honestly, it's more fun to break things than it is to build them. Finding exploitable bugs is really fun. Anybody out there do exploit dev? Few people? Yeah, you got to do fuzzing to find the exploits. I've done a couple of exploits just for work-related use that have been really simple, so I'm very much a beginner at that. More thorough testing. Generally, when you fuzz, you can get input that users or programmers often don't consider or can't make, like a lot of encoded stuff or passing nulls and that sort of thing. Fuzzing definitely helps increase your software quality, but in my mind, the most important reason to fuzz is it helps hold your vendors accountable for poorly written and poorly tested code. I can't count the number of times that I've done fuzz testing on something that my company has bought and it's just totally fallen apart. So, and then you get back with the vendor and you say, hey, can you fix this? And they say, well, why did you pass that in the first place to the input? It's only supposed to take, 1 through 9. It's like, well, okay, test your crap.
Nobody would do that, though.
Yeah,
no regular user.
Exactly. No regular user would do that. Okay, fuzzing methods. Basically, I kind of boil it down to 3. There's manual, where you just put stuff in yourself. Automated, using a fuzzing software, writing your own fuzzer. And I threw the wireless in there because I've messed a little bit with MDK3 and Kali, but not much more than that. It is kind of interesting, though, so that's something I want to put on my to-do list. Types of fuzzing, basically I see it as just 2, local and remote. Local being fuzzing something that you've got on your own machine. As far as I know, you pretty much got to do that for exploit development. It gives you full control over the environment, so you got everything in one spot. Remote fuzzing, something that's installed elsewhere, like a web application. A lot of what I deal with is web applications, but it's more restricted in terms of control. Ideally, if you can get to or look at the server while you're doing your fuzzing, for instance, if I'm fuzz testing a web application that one of our developers did, you can get pretty immediate feedback on how it's going based on how the server is responding or not responding. But the downside to that is routers, switches, firewalls, stuff sitting in between can be kind of problematic depending on how they're tuned. So something to holler at your network guys about. Software, basically anything allowing interaction with your target can be considered a fuzzer. For Windows, the 2 that I have used, Peach Fuzzer, the public edition, the community edition. I know they have a professional edition. I've not used it, but I've watched some of the videos on it, and it looks pretty decent. Burp Suite for fuzzing on Windows. I mostly use Kali, Burp Suite, Bed, Duna, .pwn, those other ones that you see. Spike and OWASP Zap. The Nmap fuzzer scripts are pretty decent. In terms of fuzzing on Windows, Peach Fuzzer, the community.peachfuzzer.com is a good website. They've got all kinds of good tutorials there. The Peach pits, the fuzz definitions are done in XML, so having a good XML XML editor, is helpful, but it's not required. The XML for the Peach pits isn't particularly complex, but having a good editor will let you kind of grid stuff out properly so you can follow it well. There are a number of Peach pits available on the internet. When you install the Peach Fuzzer, they've got a samples folder that's got some good templates and stuff in there. Peach has good feedback on reproducing crashes and logging info, and I've got some examples of that in a bit. Like I said, the tutorials are really good. I'd highly recommend working through those. If you've never worked with Peach Fuzzer before, those tutorials will really bring you up to speed quickly on Peach. And that link at the bottom is essentially a collection of other links that a user on the Peach forums posted, listing various different resources that you can go to bone up on fuzzing and kind of get your feet wet, so to speak. I can't think of the guy's name, but he posted a number of different links for beginner, intermediate, and advanced fuzzing, so it's really helpful. I refer to it regularly myself just to kind of refresh my memory. There are some gotchas with the community edition of Peach Fuzzer. I reported these bugs a while ago and essentially got back a response saying, well, we're more interested in our paid product, so we'll get to this eventually. Okay, well, that's fine. No big deal, really. These mutators are simply misspelled. So if you spell them correctly, they won't work properly, so you have to misspell them there. Not all of the samples on Peach work out of the box, and those Peach pits can be tough to write and debug. So when you're getting started with Peach, you definitely want to stick with something simple first and then kind of expand on it from there. It's not too hard to make a Peach pit for HTTP traffic, since the HTTP specification is fairly simple, so it's not too difficult to do one of those. And as I was working through one of the tutorials, I found out that this particular mutator can kill Windows when you're fuzzing WAV files. So depending on what you're doing, what you're fuzzing, you may want to exclude certain mutators, and I'll have an example of that. Some tips on running Peach. You just run Peach at the command line, and it just gives you a list of all of its options. Peach-T will validate your Peach pit. Doing a -1 will just sample run it, but not apply any mutators to it. It'll just run it with the data that you give it, and then it does its thing. So you can see how it works, how it calls your target program, and then assuming you pass the correct data through the Peach pit, your target program will return what it's supposed to return if you were to give it valid input. Peach-C will give you a count of the test iterations, which will let you know how long it may take. Peach-P will let you run Peach Fuzzer in parallel, but it doesn't do any networking. It just divides the number of test iterations by the machine. So with some simple math I put there, if you have 30,000 test iterations, it's just going to divide it in thirds on each machine. So especially when you get up into the areas like if you're fuzzing HTTP, for instance, and you've got a big request that has a lot of request headers, you may want to split it among multiple machines so your fuzzing will finish faster. You can quickly run into tens of thousands or hundreds of thousands of iterations depending on the size of your HTTP request. Okay, so I built this Peach pit from the online tutorial, and like I said, I apologize, you guys in the back may have difficulty seeing it, but I'm going to put this presentation as well as all of the samples and examples on GitHub afterwards so you can go through it. But basically, the way this breaks down is that the data model describes the data that Peach is going to consume. In this case, it's going to be a .png file, so it's just defined as a blob. The state model defines how Peach is going to interact with it and then where it's going to pull its info from. So in this case, it's referring to this PNG. I've got the test data in this case loaded into the PNG test files folder. It's going to pull out every one of the .png files there, mutated in some way, either flipping bits or messing with the metadata, whatever kind of mutators that you've applied to it. And then the action type call is going to actually launch the process that you want to fuzz. In this case, it's the MS Paint that you can see down in the agent area. So essentially what this is going to do is that it's going to launch Paint with the fuzz.png that is coming from this area. So it's going to pull a file, mutate it, rename it to fuzz.png, and then call MS Paint. Peach does require the Windows debugging tools. That's what the WinDebug path there is for. The documentation says that you don't have to supply that, but Peach rarely can seem to find it, so I just spell it out literally there. Start on call just does the launch viewer, which then launches the Paint process. And then CPU kill true. If the CPU spikes at 100% for a certain length of time, then Peach is going to kill that fuzzing session and then move on to the next one. The monitors that you see at the bottom, in this case, I'm watching the heap, and on the next page here, okay, it's just the heap, I think. Yeah, just watching the heap there. The publisher class says, okay, this is my fuzz input from my folder of files where my PNG files are located. Strategy class random, I'm going to randomly hop around through the various mutating cases. And the logger class is where I'm going to log output from the fuzz run. So if on the, say, the first time and it runs through and Paint doesn't crash or do anything odd, it's just going to iterate a counter. When it does crash, then that's where things get more interesting, and Peach log is really helpful, detailed info on how to take your crash case and then weaponize it through an exploit. It gives you a stat dump, traces, and all that kind of good stuff. So a pit to fuzz a command line that takes one program. Relatively similar. In this case, the data model is the name of the program I want to fuzz. The extract.exe, which was something that was built by one of our programmers. The way this program worked was it took parameters separated by spaces, so that's the reason for the space right after the extract.exe. I defined another data model with the parameter, which the first run through is going to be C:\scans, so it outputs an extract to the scans folder. If we wanted to, if we had a command line program that you wanted to fuzz that took more than one parameter, you would just define different data models, and I just called it arbitrarily parameter 2, parameter 3, so on and so forth. The state model, in this case, what it does is it's going to build a batch file which then has extract.exe space parameter in it. Now, I'm not really interested in fuzzing. In this case, I wasn't interested in fuzzing anything but the parameter to the extract.exe program. That was why I laid out the data model and the state model the way it is, and the tutorial goes into more in-depth stuff on this. But as before, if we had a command line program that took more than one parameter and you wanted to fuzz those parameters, you would define them in the state model here, output parameter 2, output parameter 3, so on and so forth. So, and then the action near the bottom where it's making a call to a run program method which actually runs the batch file. and this fuzzing was taking place on a Windows machine, hence the Win agent. The command line, you can see that it actually calls it's going to call the call_program.bat, which has my target program and then the parameter that I'm going to fuzz. The Win debug path, don't want to kill the CPU if it spikes at 100% in this case. And then depending on what you're fuzzing, you may or may not want to use for the wait for exit on call or wait for exit timeout. Those you may want to leave. I go back and forth on it. Sometimes I leave them as they are as the defaults just because that seems to work for me. But if you start getting weird results or your target program starts hanging, you may want to use one or both of those to let the program finish its process before it goes to the next fuzz case. So we're watching the heap again, and this little pop-up watcher here, if you have a program that has a pop-up that has to be responded to before going to the next case, Peach can handle that. If you give it the name of the pop-up window, Peach will close it automatically, go to the next fuzz case, so you don't have to sit there and click and dismiss a window if you're going on a long fuzzing run, for instance. Pretty nifty stuff. So we're wrapping it up here in this test case. Strategy class sequential, I'm going to go literally from 1 to the end of the test cases that Peach defines in the fuzzing run. The publisher class here, the call_program.bat that you see, that is the actual container of, as I said, the extract.exe space and then the parameter I want to fuzz. I'm writing logs to that area. You can write the logs anywhere. I just left it there at the default because that's where I liked it. And then excluding mutators. Depending on what you're fuzzing, you may not want to bother with fuzzing every single case, although that gives you the best fuzzing coverage. It may chew up time that's going to give you unnecessary results or stuff that's not valid for what you're doing, so you can drop certain mutators. And like I said, there's a big list of all of the mutators on the Peach website that the Peach developers went through, so you can see what the mutator does and then make a determination whether or not that's going to be useful for you in whatever program it is you're fuzzing. So you can drop them. You notice there near the bottom the misspellings, so if you were to spell those two mutators correctly, it would ignore them, or Peach may throw an error when you try to run it. So I wanted to make sure I had that in there.
You included that, right?
Yes.
Okay.
Yeah.
They don't tell you they're misspelled.
That's right. They don't tell you that. You have to actually try to run it spelled correctly, and then it dies, and then you wonder what's going on.
Okay.
Okay, so logging. Oops. I got to jump out here for a second to show you this. The way Peach logs, like I said, is helpful to let you know exactly what's going on. So when it hits something that's an error, where the program throws an error and crashes, it says, okay, I can do it once. Can I reproduce it? So in the faults folder, and this will be a subfolder under wherever you got Peach logging. So if you've got Peach logging to my directory /logs, then within that there will be a fault and then the specifics on what's going on. So you can see here we got a memory address and it says exploitable. The 17821 was the specific test case that it died on. So within that, we've got an initial. So this was the first time fault, what it died on the first time. So in this case, there's my program, and then this was the parameter passed to the extract.exe that the extract.exe program died on. So Peach says, okay, it died once, and it wrote the debugging stuff here. So then one level up, it says, okay, it died once, I'm going to try to reproduce it. You don't have to try to reproduce it manually. Peach is going to try a second time with the exact same input to see if the program crashes a second time. So there's the extract.exe, and same string as before, what killed the program. And so it says, okay, I was able to reproduce it. This is most likely a bug that I think is exploitable, and here's why. We got the Windows debug engine description, and it pulls this from the Windows debugging tools that you've got installed. So we've got a stack trace and all this good stuff here. And then near the bottom, you can see bug title, user mode write, access violation starting at this area. They're not near null, so it's exploitable. So something, if you're writing exploits, it's like, oh, okay, this is worth looking into here because I've got a reproducible crash that happened in the same way with the same string, and according to what the info here tells me, the debugging engine and all this good stuff, which, like I said, I am not an exploit developer yet by any means, but Peach logs all this stuff with the help of the Windows debugging engine, so you can, as an exploit developer, start the process of going through writing your skeleton exploit and hopefully weaponizing it. Oops, actually I didn't need to close that because there was something else. If you get a false positive, and Peach refers to something as false positive, if it can't reproduce it, you'll see something more like this, non-reproducible, and a directory named unknown or unavailable or something like that, where Peach says, okay, I could crash it, but I couldn't make it crash a second time in a row, so I'm going to assume that that's not going to be something that's exploitable. If you were doing exploit development, these would probably drop to the bottom of your priority list just because they're not as likely to lead to remote code execution. But Peach logs its way around through the status text file, and it will tell you iteration 100 of the total, iteration 200 of the total, so you can see along the way how far it's getting. So pretty nifty stuff. Oh, well, let's just jump ahead a little bit. Okay, it still didn't work. Bear with me. Okay, switching gears to Burp Suite. Burp is not really a fuzzer per se, but repeater is handy if you're doing manual fuzzing because you can just simply grab the intercepted request, the HTTP request, dump it over to a repeater with a right click, and then twiddle with it however you want. I like to use it for manual fuzzing of web applications. Decoder and compare, depending on what you're doing, are pretty handy as far as unraveling base64 encoding view state on .NET apps, for instance. That's a little hard to see, but this particular application that I was dealing with had this image handler item in it, and it took a query string parameter of an ID, so I put the, just as a marker to myself when I was stepping through it, where I wanted to insert my fuzz data, and then I wanted to try to fuzz the ASP.NET session ID cookie, so I marked that with a fuzz data. Like I said, that's not a Burp Suite function per se, but just a marker for me saying, okay, these are the areas that I want to come back to after I've gone through the various points of the application.
You consider using intruder?
What's that?
Intruder?
I have once or twice. I don't have the pro version of Burp Suite. I'm just using the free version. But I'm still working on trying to figure out my way around Burp Suite and then getting some funding to get the pro version of Burp. Okay, switching gears to the Kali Linux stuff. BED, the brute force exploit detector, it's very vulnerable. Been around for a long time. Anybody use BED? Anybody run it? Okay. It's a network protocol function. They've got modules for FTP, SMTP, HTTP, several others. There, it has a set list of strings for fuzzing, so it doesn't do mutation like Peach does. You can add your own strings by changing the code. It's Perl, and it's pretty easy to follow. It's a general use fuzzer. You kind of fire it off and forget it. Depending on what you're doing, you might want to mod some of the modules to pass in specific things. I've used it a lot for HTTP. Like I said, I deal a lot with web applications. So, and HTTP being a fairly simple protocol, you can mod the bed modules however you like. Bed does not have very good feedback in terms of what caused the crash, so I'll start up Wireshark or T-Shark or something like that so I can get a packet capture going so I can see exactly what goes on if I get a crash. These are the fuzz strings that Bed uses. Bed was designed and developed primarily to fuzz C applications, so there's a lot of C-related stuff there. The format strings for C there you may recognize, along with the Unicode stuff and large numbers. So these were items that the developers put in that often cause crashes, or at least instability in programs. Duna, it's a expansion, a fork of Bed, same as Bed, really a network protocol fuzzer. It has a more comprehensive list of fuzz strings, so it's more likely to crash stuff simply because it's got a bigger payload to draw from. Also written in Perl, so you can add your own fuzz strings or move depending on your needs. It's fire and forget, so you just kind of kick it off and then wait for it to run. And just like with Bed, I always start packet capture before using it so I get better visibility into what causes a crash. The fuzz strings you can see here there's a few more, specifically the format strings. Near the bottom there's some more interesting looking format strings, a few more large numbers, some different miscellaneous strings that you can see there. So it's a little more comprehensive. But depending on what you're doing, you might use Bed, you might use Duna, you might use both. So, you always pick the tool that works best for you. .pwn, it's good for finding directory traversal stuff. It's got a huge list of various ways to do .. so it works really good for that. I had to edit the Perl module there, the traversal engine.pm, to look for specific target files I was looking to find in a directory traversal. So depending on what you're doing, the default out-of-the-box install that comes with Kali may work for you, or you may need to modify it. I've found it's best to run .pwn after you're doing a fair amount of recon. .pwn will run without any of the special options and stuff that you can pass to it, but if you can tell .pwn what platform it's on, then it's going to run a whole lot better, and it'll cut out all kinds of stuff that you won't need. Like if you're fuzzing a Windows box, for instance, you don't need to have it look for the Etsy password or the Etsy shadow, that sort of stuff. The E and -X parameters will help intensify your directory traversal attacks, so those are good to use. And if you're using it on a web server, don't forget the -M parameter to switch HTTP methods between GET and POST. And it's a screenshot of some of the .pwn stuff. The third grouping down, the extra files, that's where you can change or modify as you see fit, depending on what target files you're looking for. And you can see there near the middle of the screen the representations of the dots and the slashes that .pwn will cycle through to try to get directly traversal on the target that you've pointed it at.
Will it also try other HTTP methods?
Not on its own. You have to tell it to via that -M parameter. If you don't give it the -M parameter, it's
try delete or something like that.
You would. Well, the question was, will it do different? .pwn do different HTTP methods? You would have to describe those on the parameters. -M, post. I think they're comma separated, so you would do -m, post, update, put, delete, whatever other methods you want to use. The Metasploit has some good fuzzer modules. Has anybody messed around with the fuzzer modules in Metasploit? Anybody know about them? They're not particularly, I see a couple hands go up. They're not particularly well advertised in Metasploit. I'm not really sure why. They're good. They're fuzzers for DNS, SMTP, HTTPs, a few other protocols. That path that you see there on the screen is pointed toward, that's where you can see all the fuzzers that are available, or you can just do a search fuzzer within the MSF console to pull them up. I've had good luck with SMB and HTTP fuzzers. I haven't really used many beyond that. So far, I haven't had a need. Most of the modules, the fuzzer modules, I think support the threads parameter, so you can bump that up and finish your fuzzing a bit faster. And the Metasploit fuzzer modules provide some pretty good feedback on what causes a crash, but I still run a packet capture just so I've got all the data I need. That big, long, ugly path there to fuzzer.rb is the Ruby code for how fuzz strings are created, and that's worthwhile to look at. You don't have to know Ruby to interpret this, even if you've only done just a tiny bit of programming. If you look at it and run down through it, it'll make sense, and you can see how the Metasploit builds the fuzzer, the fuzz string. So it's a pretty good reference. The TDS login corrupt and TDS login username are good for fuzzing SQL Server. The code is a bit dated now. You might have to edit it to send the correct TDS version for SQL Server. I think the modules send the TDS version for SQL Server 2000, which hopefully nobody's still running SQL Server 2000. Would anybody admit to it if they were? I know I wouldn't. But those two links there to Microsoft's website define where the TDS version is and specifically how to structure it, so you can go in and change the Ruby code to point it to the right TDS version. Within Metasploit, those three fuzzer modules, HTTP form field, get URI long, get URI strings, those are good. The SMB2 negotiate corrupt is good. It sends bad negotiation packets via SMB2, and that can cause some interesting crashes. The Nmap fuzzer scripts, nmap.org/NSE-doc has good documentation on all Nmap scripts, not just the fuzzing ones. They've got a DNS fuzz one. I've not used it yet, but I have used the HTTP form fuzzer. It will go through and scrape the fields on a form and then fuzz each one. So it's pretty good for just kicking it off and just letting it go and watch what it's doing. I don't work with PHP code myself, but there is a PHP fuzzer there, but it looks pretty interesting just glancing through the code. I've not written a line of code in Lua, but it looks fairly self-explanatory. You can find all the scripts for Nmap in the user share Nmap scripts directory. So if you're up on Lua or want to do some modding, they're all there for you. Spike. Spike's been around for a long time. Tough to use, but pretty powerful. I don't know C that well, but the better you know C, the more mileage you can get out of Spike. There's a really good tutorial on it at the infosecinstitute.com, and that's where I started learning more about Spike. Kali comes with some pre-built spikes in that area that are useful, but 9 times out of 10 you're going to have to modify them for your particular target. There are 2 basic commands. I think there's more, but there's only 2 that I've ever used in Spike. The generic send TCP and generic send UDP. They send TCP and UDP packets respectively. That's IPv4. It doesn't, as far as I know, Spike doesn't support IPv6. It's got some admittedly weak documentation in the user share doc Spike, but the best way to learn Spike and to really know what it does, assuming you've got a reasonable knowledge of C, is to just look at the code. You can search the spike.c for the init fuzz ints, and then look for fuzz string, and you'll see the fuzz strings that are used. Kali does not come with a spike source, so you've got to pull it from somewhere else. The last time I looked, it was at fuzzing.org. There was a spike file link there. Kali only has the compiled version of Spike, so you can't actually see what it's doing if you're interested in modding Spike or looking to see what kind of fuzz strings it's using. You'll have to pull a copy of the source from that area. It may exist elsewhere, but when I just did a quick Google search, that was the first thing that came up. Okay, a Spike for fuzzing HTTP GET. Like I said, you don't have to have a good knowledge of C, but the more you know about it, the more use you can make a Spike. Basically, you just lay out your HTTP request and then separate it with a carriage return line feed. So in this case, the S string is a constant that won't change. When you use S string variable, it will pass that the first time on the first run of the Spike, and then for the subsequent runs, it's going to replace that with its fuzz string. Another one, in this one, I'm wanting to fuzz the value of the query string TID, so that's why I broke the get up into 2 lines so I can see clearly, okay, this is the spot I want to insert my fuzz string. The fuzzing the web resource.axd, if you're on .NET, it's always a good idea to fuzz that when you're testing applications. And I wanted to, in this case, test the D query string. And I didn't care about breaking up the T query string, testing that separately at the time, but you could just by busting the line up into multiples and then putting the S string underscore variable in the spot where you wanted to insert your fuzz string. Okay, fuzzing post. The neat thing about Spike is it will calculate the correct content length if you're fuzzing a post request, but you've got to do it within a specific block. That's the reason for the insertion of that S block size string. I know that's near the bottom, but like I said, I'm going to put this online so you'll be able to see it. So as long as you define the, in this case, the body of the post that I wanted to fuzz, the view state in this .NET application within a block, then every time Spike iterates through and it grabs a new fuzz string, it's going to recalculate the content length. So it's going to pass it over correctly, and the web server, the receiving web server, won't just reject it out of hand with an HTTP error code that the content length is wrong, which is kind of cool. Okay, Peach Fuzzer on Kali works pretty much the same as Windows. You've got to get the mono packages. If you're on a Ubuntu or Debian distro, you can just do an install mono complete with the apt-get. See, I'm running a little short on time here. So some general tips and tricks. Mess around with your target first. Get an idea about what it does, how it works, before you launch a fuzzing run against it. This will let you tailor your fuzzing to your target. Knowing what input the program expects will let you know what it doesn't expect, and will kind of lead you to the third thing there, to ask yourself, what are the best or worst inputs that I can pass that will cause damage? You know, as I'm sure we all written some code before. Programmers code for certain types of bad input, but it's almost impossible to catch everything because most programmers don't do whitelisting of input. They'll have a block that says, okay, I want to reject a alphanumeric or an alphabetic in a numeric field, for instance, but they may not do bounds checking, length checking, or stuff like that. So try mixing special characters and spaces, carriage returns and line feeds and stuff when you create your fuzz strings, just to see what the program does. For .NET, like I said, I work a lot with web applications, .NET stuff in particular. Try passing format strings to a .NET input, like the 0N2 or the date formatting string, just to see if your target program blows up. Using virtual machine software, VMware or Oracle VirtualBox might be helpful when you're doing fuzzing. Same thing goes for spare hardware. Use it for fuzzing practice. If you've got some old wireless routers or access points hanging around, break out MDK3 and play around with it. It's disruptive by nature. Be prepared to reboot your target. I found this out the hard way when I was starting out, that I didn't let the network admins know, and all of a sudden they started seeing this crazy traffic going through a web server, and they said, "Oh man, we're under attack." No, it's just me. I screwed up. I forgot to let you know. The dev.modern.ie has some free time-limited virtual machines that are good for fuzzing targets. That's a Microsoft site. You can get a variety of different VMs, I think VirtualBox too, with different operating systems on them and different versions of Internet Explorer, so you've got a pretty good resource there. vulnhub.com has some good challenges with downloadable virtual machines, not specifically fuzzing related, but good resources nonetheless. And the ExploitDB has a couple of good write-ups there on fuzzing, and I review those periodically just to kind of refresh my memory and see if I can learn something new. Start with a short fuzzing run at first to make sure that everything is good. Just a few iterations to make sure that the program, your target program, is responding or not responding, as the case may be, to see what's happening. Make sure you're getting feedback from your fuzzer that's useful for you, like a packet capture or logging or something like that. Stuff for Windows, simulate production as closely as possible so your fuzzing run will be as accurate as you can make it. I put that in there about watching for antivirus and anti-malware, including Emmet. I have not yet seen antivirus or anti-malware or Emmet catch a fuzzing run. I don't know if that's by design or what, but I stuck that in there anyway, just to kind of, if you see odd things happening or something that you're not expecting, see if maybe the anti-malware or if you're running Microsoft Emmet is tripping you up. Especially on Windows, you tend to run your target out of memory, particularly if you're using Peach. I don't know if that's because of a memory leak in Peach or just the way Peach works. Control-Alt-Delete is your friend on your target. Some tips with Kali, and this is just, your mileage may vary, but I usually start with the general purpose fuzzers like BED or Duna, and then progress to the other ones I needed. Depends on what I'm fuzzing though. That method works well for me with web applications. BED and Duna are currently having some problems. The last time I did a apt-get update and dist upgrade on Kali, it pushed Perl to a new version there, 5.22.25, and that broke BED, Duna, and I think it broke Uniscan. But I got in touch with the Duna developer, so shout out to WireGhoul on that. He was very helpful to provide a fix, and I backported that to BED, and that worked there. And I reported this on the Kali bugs page, and I think it was yesterday I got a response from one of the Kali devs that they're going to push this into the repos. But I don't know if it was going to go out this week, next, or even in another version. But there is a fix in place for BED and Duna, but you just have to do an apt-get and see when it comes down. I've got that link there has the fixes in it. So if you need BED or Duna and the fixes haven't been pushed to the Kali repos, then you can apply the fixes yourself. It's just a handful of lines of code. No big deal there. But check the fuzzer source to make sure it's sending the strings you want. You might need to customize them based on your target. So if you're working on, for instance, a Apache box, you wouldn't want to send .NET-based fuzz strings to it. Or maybe you would, depending on what's going on and what your program is. Start a packet capture before you begin your fuzzing run. Some tools don't give good feedback, so especially if you're doing exploit development, you want to know exactly what's going on over the wire when you do your requests and get your response. That's pretty much it for me. I'll have the samples up at my GitHub page there. I had to add some extra Ds because the grid with one D was already taken, unfortunately. But make fuzzing part of your development or QA process. It does help, but it's going to drive your programmers nuts. That's okay; they'll get over it. But I'll be around. Stop and introduce yourself if you want. And my email address there, diverdown10@gmail.com. You can reach out to me. I've got maybe about 5 minutes. Anybody have any questions, comments? Yes.
Have you ever had to use anything that goes through the front end that will run through like a browser or a physical application, doing sentence like that?
Not yet, and
Can you repeat the question?
I'm sorry. The question was, have you ever had to send anything through a front end using send keys or anything like that?
Like Selenium or something?
Yeah, to Selenium or something like that. I haven't yet, but it looks interesting. It's something that I want to put on my to-do list based on the program. I've got some stuff in the pipeline where I have to do some fuzzing on Windows-based applications, so I think that's where that's going to come in, but I haven't done it yet. Any other questions? Yes.
You tried, you were talking about one of the topic, Wireshark and stuff, to see traffic. Have you ever tried something like D-Trace on Unix systems to see what the file system's doing, or what the network's doing?
I think I used D-Trace some time ago, but I haven't recently, so my memory's a little rusty on that, but that might be a good tool to kind of keep watch on things. Okay, thanks. Appreciate the tip. Any other questions, comments? No? Okay, that's it. Thanks for coming.